This here is an EPLAN tutorial. I want to show you how we create a project from scratch. Of course, there's a beginner's guide you can look into. I'm going to do it a little bit faster here. Project new, create a new project. Test 1 is going to be my name. Here the template I pick, NFPA base 004. It's a derivative of the original one just because it contains a few more pages. You can choose an APT or a ZW9. I prefer ZW9s because they actually contain everything that has to do with a project. We're talking about symbols, plot frames, forms. And eventually these considered master data will not be up to date. It will ask you if you want to update them. The description of the project is a one-time thing. You do it once, description. You give it a drawing number. This drawing number shall be a unique drawing number for the whole project. Otherwise, we have a job and drawing numbers per pages that you can also assign. These are properties on each individual page. As you can see, page number 2 is a 1-ladder plot frame, 2-ladder, 1-ladder, 2-ladder plot frame. Typically, to keep a little bit more standard, we will use the same plot frame. Here you can choose it per page or for all pages at the same time. Now, when we insert, we can start inserting symbols. I'll jump right away into insert window macros. I'll insert a distribution block circuit, and I'll have it numbered. Numbered by means of a specific format. If my customer wants a sequential numbering, identifier counter, I'm going to use identifier counter. If he prefers the NFPA style, which basically refers back to the row number, I can just leave it as it is. It's already preset like this, so all the components are set to number by the row number they're sitting on. So that's so far, that's good. Now, some of these components may have part numbers assigned, some of them may not have part numbers assigned. Here, I'm going to go and look for a part number, but on the data portal. The data portal contains over 400,000 parts. Now here I'm looking into the Allen Bradley parts. I'm going down to B25. It's not big enough. Let's go further down. C16, it's a 16 amp. C20, it's a 20 amp, as you can see. I'm going to pick this one. This is now saving up to my system so that the next time I don't have to go to this data portal. This data portal probably represents at least 30 minutes saving, because not only that it actually gives you a picture, it gives you the size of the component, it gives you the whole commercial information, it also gives you, in some cases, some external documents. These external documents can become very handy later down the road if you need to pursue some more information about the component, because they guide you towards the Rockwell website, and directly on the Rockwell website you'll have all the information, the product details, certification, everything you need basically at the tip of your hand directly, right? So this is a big time saver for electrical designers. Now, of course, let's continue in the creation of the schematics. I'm going to pursue here with a standard 3-line phase here. I'm going to place that 1 line. I'm going to place it twice actually, and you will see something interesting. EPLAN automatically takes care of what we call the cross references. I'm just going to zoom in here so you can see. This is on page 3, line 00, goes to page 2, line 229. There we go, and this goes page 300. Now, a lot of people tell me you don't have to show page 3, line 300. We know that line 300 is on page 3. Fine. We can actually have a global setting here at the project level where we say the cross references, generally speaking, come without a page number, and that dot that comes in between, I don't need it. So I'm just going to get rid of it. There we go. We have 300 on this side. We have 229 on this page. Perfect. Now let's just continue. We have standard motor circuits, right? Motors, I don't reinvent the wheel. They always come in a certain way, and they are controlled a certain way. So all I'm doing is basically I'm choosing here what is my standard control. Now I'm clicking on the tab button, I'm placing it, I'm choosing a horsepower rating, and I go to the next one. Next one is going to be a 10 horsepower, next one is going to be a 3 horsepower again. This already did preset the part numbers for this one here. This is a B63, this one here is a B63, and this one here is a C16. All the data actually came right off the the placement of the circuit. Okay, now it also comes with all the commercial information, everything that follows with it, depending on what source you're actually pointing to, as easy as this. So if you want to know a little bit more about the components themselves, there is behind the scene a so-called parts management. This parts management, what it does, it basically gives you access to commercial information, mounting information, and function template information. Based on that information, we can actually draw schematics right away by saying, I'm going to insert a device. Insert a device, let's say a IB16 PLC card. Here we go, we have different ways, the European style, the North American style, and I can just basically place it here, boom, like this, and have it numbered. And now it's ready to actually connect. Now if I want to connect something, I can jump in through symbols. You can see here we have a bunch of symbols. These symbols come with normally open, normally closed, all the different styles that you need. Of course you can pick them here. This is a standard operated switch, push button, whatever it is, and then you can just drag and drop it down and it will place, it will number, everything. You can also set yourself some push buttons like these where you say, okay, I want a normally closed push button rather, and it's going to enter a normally closed push button. So it's basically just different ways to call up the same symbols. After you've done this, we're going to use some special tricks in EPLAN called connection symbols. These connection symbols actually make the difference whether you have a daisy chain or back to the source. An interesting thing is when you pull them down like this, just drag and drop, boom, the connection is done. You have a daisy chain between all these push buttons. You want to feed this line of power with some wires that come from a different page from that distribution page. You will be using the interruption point. Here, interruption point, hit the tab button, it rotates. I don't know if you can see very well. We'll just get closer. We rotate, 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 rotate. And when we're actually on the spot here, we can choose whichever cross-reference we want to go to. Here, 24 VDC2 is the connection we want to go to. Now, sometimes this happens. Because I rotated this one. Typically, this one would have probably shown up at the bottom there. So I'm just hitting the control key, placing it there. And at the top here, I would have preferred a different rotation. I would have preferred simply this rotation, or I would have also been able to do a different kind of change, is change the display where the display shows up at the top or at the bottom. So either rotation oriented or display oriented, you can specify where the cross-reference will be shown at the top or at the bottom of the arrow itself. And there we go, we have a cross-reference going back here to the page 224. 401 is shown here. I can jump back like this and that's done. Now the next step is to take care of terminals. Terminals are very simple symbols. They look like a small round dot, have a small tail. That tail typically indicates the inside of the panel. So the inside of the panel being on the right hand side here, I rotate the terminal, and this will ensure later that my terminal diagram, which is one of the reports I love to use, will determine where exactly this, I'm just going to call it JB1, where the push button or the PLC will be connected, at the top or at the bottom of the terminal, right? Once this is done, fairly easy, you just take the project and you're ready to do the wire numbering. The wire numbering is a two-step process. First step is placing a wire number. When you do place a wire number like this, it basically places a wire tag everywhere where there is a standard wire. Now, another thing we want to do is number these wires. Very often in an environment like this, people will number what's on the left-hand side according to the source, like 224, and on the right-hand side according to the signal, so the I/O address of that particular PLC card. Now we can see here that by default, I wasn't really careful when I inserted them. This is a Rockwell card, and typically Rockwell cards have a specific way of addressing. They usually work like 00/00. Here, this feature simply flips them around to the Rockwell standard, which is I00/00, or whichever format you want. Now, this type of format I will take over in the numbering scheme of the wire numbering. So here in the wire numbering scheme, now typically I could just go about and have it run, and it does the numbering, as you can see. But in other cases, I want to go a little bit further, and I actually would like to take over the wire number that we have. I want to take it over onto the terminal designation. This way, I don't even have to worry about the terminal designations themselves. So you can see here how it works is you have a standard scheme. In that standard scheme, you have two different wire numbering group, one for everything that's connected to PLCs, one for everything that's general, and on each of them, I have the possibility to adjust a few different things. One among themselves is the override terminal designation. When it's checked, what this does, it basically overrides the terminal designation with the wire number. So it automatically does a lot of things for me because it also sorts my terminals, it organizes my terminals, everything. Now, when you're finished with the wire numbering, all you have to do run the reports. The reports will give you the bill of material, right? The bill of material, as you can see here, is automatically filled out. The terminal diagrams, here is my junction box, my terminal strip overview. Here it is. See, it organizes all my terminals. It tells you what's connected on the outside, all these push buttons, whatever. It's all listed here. Now, interesting is that I can also, instead of showing you a terminal diagram, I could also show you a wire list. A wire list is interesting if I make a smart move between filtering internal wires from external wires. One simple step that we recommend is to assign what we call a structure box in EPLAN. Insert box, structure box. If the structure is activated in your project, you can actually say everything that's out here is in the field. I could call it field, I could call it F, I could call it C1, conveyor 1, area 2, whatever. Everything is set to be inside the panel except when it's in a box like this. So here we have the motors that are out in the field, and we have here this junction box that is out in the field, including the push buttons we see here, right? So what happens is that all these items automatically get assigned to the field, which makes such a difference because if I rerun the same menu as before, generate project reports, I now have a field wiring and an internal wiring. The internal wiring list is to be given out to the electrician that will do the panel, the inside of the panel. The field wiring is very simple. This is everything that's out in the field. We're talking about the field wiring inside the junction box. We're talking about whatever goes to the motor. We're talking about everything that's out in the field. A nice split. You can count exactly what kind of wires you have. And at the end of the day, I can spit out automatically all my labels based on the same concept. Again, I can run here what we call the wire tags right through Clip Project. So this is an interface to the Clip Project marking interface. We could also generate any type of label through something very simple as a simple marker like this. Here, wire tags, it's a text file. You hand over that text file to your Brady labeler or whatever other labeler you have, generated automatically out of the box. And finally, but not least, is the generation of the PDF file. The PDF is a smart PDF, which means we keep all the smarts we have in EPLAN in the PDF. Sounds interesting? Let's take a look. Here, we open the PDF. The PDF has a page structure, very similar to what we had before. It has even the cross-references, so basically if I hover over an interruption point like this, I can click and click, it goes back and forth between the two cross-references. Another thing it does, if you want to see more details, remember that part number that we picked for this guy? Here are the details about the part number. It even tells you the size, the component, where it is, everything. And you can switch back here to your schematics and see on the schematic where it's actually at. Another thing you can do, if you want to mark up these drawings because there is something wrong, right?